See, Nana, we are discussing by the first question in electric potential and capacitance. See, what is there? Derive an expression. Derive an expression for the potential. For the potential at a distance from a point charge. The distance from a point charge. See here, let us consider. Let us consider charge q now. So what is the? Let us consider the charge q is placed at point O. So what is the? Let us consider the charge q the placed at point O now. Now is around this charge around. So what is producing by their electric field can be produced. See, this is how the electric field. Electric field can be produced around this charge. Now let we are consider the point A. So let us consider the point A. In a electric field, in a electric field, is the distance x from point O. How much is there? The x distance from a point O. Then electric field electric field electric field due to electric field due to పాజిటివ్ ఛార్జ్ q అంటే ఈ పాజిటివ్ ఛార్జ్ వల్ల మనం ఏం కనుక్కోవాలి మనం ఎలక్ట్రిక్ ఫీల్డ్ వేర్ వీ కెన్ ఫైండ్ ఎట్ పాయింట్ ఏ నన్ను సి వాట్ ఈస్ ద ఫార్ములా ఫర్ ద ఎలక్ట్రిక్ ఫీల్డ్ E is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught q by r square. R square is nothing but the distance between the point to charge. But here the point to charge, how much is there? X. See, that's why we can write the x square. See, electric field due to positive charge at point A. At point A, how much is there? E is equal to 1 by 4 pi epsilon q by x square. Next, after that, we are consider the another charge, that is say the q naught is at infinite. Where is that? Infinite. Now this q naught charge is bring into electric field. Is bring into electric field. Economic discussion. See, this the q naught charge is bring into infinite to electric field at point A. Now here the charge is there q naught. Now here the q charge, here the q naught. But the two charges between attraction or repulsion. That means what is producing the Coulomb's law can be stable. See, if charge q naught is placed at point A and ఇక్కడ charge q ఉందని ఇక్కడ charge q naught. This between attraction or repulsion can be stable. See, that is the force of attraction or repulsion according to Coulomb's law. So what's it? According to Coulomb's law. According to Coulomb's law. So what is the formula of Coulomb's law? F is equal to 1 by 4 pi epsilon naught q1 q2 by r square. See, this is the formula of a Coulomb's inverse square. But here the charge q1 is equal to how much is there? Q. And q2 is equal to how much is there here? Q naught. And now the distance between how much is there here? R is equal to x. These three values substitute above equation. Then we get this F is equal to 1 by 4 pi epsilon naught q naught by what is it? X square. Q naught by x square. See, this is considered the equation number 1. Equation number 1. Now after that, this q naught charge is moving A to B point. A to B point, some displacement, through a displacement is there, the dx. How much of the displacement is there? The dx is the displacement between the A to B point. But this q naught charge is moving against of a electric field, because of the electric field is acting, this is the direction, but the q naught charge is moving, this is the direction. See, what is this q naught charge is moving, the q naught charge is moving A to B point against of a electric field, some work is done. That formula, work done is equal, what is the formula? Force into displacement. See, if charge q naught is moved A to B point, A to B point against electric field, against electric field, some work done. So what is the work done in the formula? The work done is equal to force into displacement. The force into displacement is denoted by the S. But here the displacement S is here the displacement S is equal to dx, and here take the negative. This minus indicates opposite to electric field, opposite to electric field, opposite to electric field. Now here the substitute here the values from equation 1, from equation 1, what is there, nana? F is equal to 1 by 4 pi epsilon naught q naught by x square. Then substitute here, this dw is equal to minus 1 by 4 pi epsilon naught q naught by x square into displacement S is equal to how much is area, the dx. But this q naught charge is not stopped by the B point, it's moving, towards the direction of a P point. ఎక్కడ వరకు మూవ్ అవుతుంది మనకు, ఇట్స్ మూవింగ్ అప్ టు P point. Is the distance, the O2 is there, the R none. Now we can find out the total work done. What we can find out, total work done, total work done by moving a charge, q naught from infinite to point P, point P. So what is that? The total work done by a moving a charge q naught from infinite to P point. Then we can find out the total work done. What we can find out here, the total work done. See, total work done. Total work done is nothing but the integration on above equation. See, integration, the dw is equal to integration minus 1 by 4 pi epsilon naught q naught by x square into dx. But the q naught charge is moving infinity to r, infinity to r. This is between the points is moving by there. That's how you can find the total work done. Now we know that in integration, the which of the constant values, write the before of integration. q naught is the constant, minus q naught is the constant, and 4 pi epsilon naught also constant. See, what is the variation? Integration infinity to r, 1 by x square into dx. See, integration of dw is equal to how much is there? W. We have know the basic formulas. Integration dx is equal to x, and integration of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. This is how the basic formulas. Now we can write here. See, what we can write, nana? See, this in 1 by x square, take the denominator, take the numerator, nana. The numerator will be taken by the minus q naught by 4 pi epsilon naught integration infinity to r x to the power of minus 2 into dx, nana. Minus 2 into dx because of the denominator. Then apply the x to the power of n dx. See, minus q naught by 4 pi epsilon naught. 4 pi epsilon naught. Extra 4 of minus 2 plus 1 by minus 2 plus 1, the infinity to r. This is the work done. See, plus 1 minus 1. Minus 2 plus 1. How much is the area? The minus 1. Q naught by 4 pi epsilon naught. Extra 4 of minus 1 by minus 1 infinity to r. And here the this minus and this minus can be gets cancelled. And extra 4 of minus 1 take the denominator. Nana. See what we change? Q naught by 4 pi epsilon naught into 1 by x infinity to r. The limits are infinity to r. Then substitute in x replaced by the r. Nana. After that we can replace by the infinity. See, right, this is the formula. The work is equal to q naught by 4 pi epsilon naught into 1 by. So what we can, the x replaced by the r. Nana. R minus 1 by infinity. See, 1 by infinity is nothing but 0. It's negligible. Nana. The remaining what is there here? The q naught by, see, 1 by r we can write here the 4 pi epsilon naught into r w. And this q naught, only this q naught is taken to this side. No? The w by q naught is equal to 1 by 4 pi epsilon naught into q by r. No? This q by r is 1 by 4. But we know that, so what we know that? We know that electric potential, the V is equal to amount of work done for unit charge. Amount of work done for unit charge. The W by Q naught is equal to what we can write here? The V is equal to 1 by 4 pi epsilon naught Q by R. See, this is the formula for the electric potential due to a point charge. Electric potential due to a point charge. See here, we are discussing whether what is the topic. Derive an expression for the capacitance of a parallel plate capacitor. See, let us consider two parallel plates. Two parallel plates. Two parallel plates of area. Two parallel plates of area A. So that area will be same, are separated by small distance d. The small distance is d. See here, we can draw this diagram now. See, this is how the first plate. This is considered the positive plate. What is considered a positive plate? See, this is considered the another plate. Another plate. It is considered the negative plate. So what is considered this a negative plate? This is also the positive charge. It is the negative charge. And this area of cross section, how much is there? A. And these two plates are separated by the distance is small d. These two plates are separated by the small d. Let Q అంటే మనకు charge. Let Q is charge on each plate. Q is charge on each plate. Is surface charge density is surface charge density is denoted by the sigma. We all know the three densities. One is the linear charge density, surface charge density and volume charge density. Length paranga measure chesthe the linear charge density, and area paranga measure chesthe surface charge density. The volume paranga denote chesthe volume charge density. See here, the surface charge density, the sigma is equal charge per unit area. What is the formula is here? The surface charge density sigma is equal to charge per unit area. But we can observe here the one is the positive plate, another one is the negative plate. The positive is always attracted with a negative. See now what is stable by the area? The electric field can be stable. See therefore electric field between between the plates between the plates, that electric field formula is there E is equal to sigma by epsilon naught. It is already derived by a electric charges and field chapter. That is application of a Gauss law, second application. See that is what is it? Electric field between the plates. Electric field between the plates E is equal to sigma by epsilon naught. Now here this sigma value substitute here. This sigma value we can substitute here place. Then the electric field E is equal to Q by A epsilon naught. What is the electric field? E is equal to Q by A epsilon naught. This is considered the equation number 1. We know that. So what we know, the relation between electric field and potential. Electric field and potential. See that is the formula. V is equal to E into D. So what is the formula? Is the relation between the electric field and potential? V is equal to E into D. Now this E value from equation 1. E is equal to how much is there? Q by A epsilon naught. We can substitute here place. The V is equal to Q by A epsilon naught into D. A epsilon naught into D. Now this Q is taken this side. See what is there? V by Q is equal to D by A epsilon naught. See what is there? D by A epsilon naught. But we know that. So we know that. What we know that? The capacitance. The capacitor of capacitance C is equal to Q by V. So what is the capacitor of capacitance? C is equal to Q by V. Now here what is there? V by Q. And the denominator is take the numerator and numerator take the denominator. Then that is the capacitance C is equal to. It is also taken the denominator is take the numerator and numerator comes to the denominator. The C is equal to A epsilon naught by D. See this is the formula of A. What is the formula? The capacitance of a parallel plate capacitor. Capacitance of a parallel plate capacitor. The C is equal to A epsilon naught by D. A epsilon. The question is, explain series combination of capacitor. Derive the formula for equivalent capacitance in each combination. See, let us consider three capacitors. Capacitors of capacitance. Three capacitor of capacitance C1, C2 and C3 are connected in series. See, we have this is the three capacitor. Now each capacitor having two plates. Each capacitor having the two plates. One is say the positive charge, another say the negative charge. This is the first capacitor. Okay, and the next capacitor. See, this is the second capacitor. Okay, this is the positive charge and it have the negative charge. And next third capacitor. This is how the third capacitor. Again, it have the two charges. See, one is the positive charge and one is the negative charge. Now these two charges of the capacitance, what is it? C1, C2 and C3. C1, C2 and C3. C1, C2, C3. Now is connected across as a battery. What is connected? Across as a battery of positive and negative terminal. So this is a positive terminal and it's negative terminal. Now in this one, when the battery is dividing of three potential because of each connected in a series combination. Now the first capacitor is potential difference is considered by the V1. Potential difference is V1. And the second capacitor of the potential difference we consider the V2. And the third capacitor of the potential is V3. In series combination, the potential is dividing by the battery. The battery is dividing the equally of the potential. The first capacitor of V1 and second capacitor of V2 and third capacitor of V3. And also observing for the connection. The first capacitor of second plate, is connected to the second capacitor of first plate, and the second capacitor of second plate is connected to the first plate of a third capacitor, and finally the third capacitor of the second plate and the first capacitor of the first plate is connected to the battery of positive and negative terminal, and the total the variation of potential difference is V none. And that means it is the negative is connected to the positive and negative is connected to the positive. That means the potential of the variation is there V1, V2, V3. Therefore, total potential difference. Therefore, the total potential, the V is equal to V1 plus V2 plus V3. V1 plus V2 plus V3. But we know the capacitor. What is the formula for the capacitor? The capacitor of capacitance is C is equal to Q by V. But here the charge is constant. The charge is constant in series combination. So what is variation? The potential can be variation, that V is equal to V1 plus V2 plus V3. Then the C is equal to what is there? Q by V. C is equal to how much is there? Q by V. The similarly we can write here take the cross multiplication. The V is equal to write Q by C. Now V1 is equal to Q by C1 because of the charge is the constant. That's why we are not writing here the Q1. And similarly we can have the V2 is equal to Q by C2 and V3 is equal to Q by C3. This V1, V2, V3 substitute in a above equation. Then we can write here the V is equal to how much is there here the Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. Now take the common for the Q. The Q by C is equal to, the Q will be like a common 1 by C1 plus 1 by C2 plus 1 by C3. Now the Q can be gets cancelled. This 1 by C. See 1 by C is nothing but effective capacitance in series combination. The 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula of a, what is it? The effective or the equivalent, the capacitance in each combination. That's a 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. If n capacitors are connected in series. అంటే ఇంతకుముందు మనం ఎన్ని కనెక్ట్ చేసామన్నా, ఇయర్ ఈస్ కనెక్టెడ్ బై ఓన్లీ 3 capacitors. That's why say the 1 by C1 plus 1 by C2 plus 1 by C. But it is connected by the n capacitors. Then the 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus and so on 1 by Cn. See, this is the formula. Now can